Okay, today we're talking about Chapter 1, Section 7, the chain rule. So this is, don't really care about the story about shoes. Of course, you can read it on your own. I don't think it's, I mean, it's okay, but I'm not going to snip it this time. All right, so now we're going to get into something a little more computation intensive, a little more tedious, and that is the chain rule. Okay, but before we talk about chain rule, let's talk about composite functions first, because composite functions, hopefully that doesn't drum up too much anxiety in you, but composite functions are how we begin the process of the chain rule. Okay, so let's start here at the top. The definition: the composed function f of g, the composition of f and g is defined as, okay, so composite, same thing. It is defined as f, and then there's an o there, like a little bitty o. I mean, it just means f of g, right? Don't confuse it with a dot like so, which means f times g. Okay, f of g of x, and of course that's the same thing as saying f, and phonetically, of g of x. Okay, and that's what a composite function is. There's a visualization there, and let's just try to walk through it. I don't think these visualizations do much for me, or at least they didn't when I was a student. But let's visualize it. So we're going to input some x, some number, right? We're going to input some number x. We're going to input it into g. All right, and we put that number into g, out comes g of x. Okay, keep in mind right here, this entire machine is f of g. Okay, so we put an x, and it first goes into g, and out pops g of x. And then we put g of x into f, right here, the blue one. We put g of x into f, and we get f of g of x, which is, well, f of g of x, or again, phonetically is the exact same, f of g of x. All right, so to find f of g of x, we substitute g of x in for, we substitute g of x for x in f of x. The function g of x is nested within f of x. Okay, so again, that's a lot of words there. All right, but let's try to walk through this one. Example 1 reads, for f of x is equal to x to the fourth and g of x is equal to 2x plus 2 plus 3 to the x, find f of g of x and g of f of x. Okay, so we'll do the first one here, f of g of x. So f of g of x, and let's see, I'm probably gonna run out of room, but we'll try this anyways. Okay. The way this works is what you're gonna do is you're basically putting g into f. Okay, it's f comprised of g of x, right? Normally let's do this. So let's say we have some f of x, and let's say it's equal to 7x plus 3. Okay, well, if we did f of 3, that's a different number, f of 2, right? Well, then what you do is you plug that 2 in for x and then proceed. Okay, it's pretty much the exact same principle, except now we're not inputting an x, we're inputting an entire equation. Okay, so we're not putting a single variable in, we're putting an entire equation in. So let's start off. All right, well, what is f? Well, f is down here. It says f of x is equal to x to the fourth. Okay, so that's f. Okay, so what we have to do is we have to plug g into f. Okay, well, everywhere where you see an x, you're going to plug in a g. Well, lucky for us, there's only one x. Okay, so all we're going to do is simply plug in g, and g was 2 plus 3x cubed, so 2 plus 3x cubed. We plug that in for x, and let's do it this way. I want to color coordinate again. I think it's handy. It helps the students out. So f will be blue, and then g will be yellow. Let's try that again. Of x. Okay, so again, f was simply x to the fourth. Okay, well, we need to substitute g where we see x. So we're just going to simply erase the x here. We're going to plug in a g, and the g was 2 plus x cubed. Okay. And that's f of g of x. Next, we'll do g of f of x. Right? And then g was 2 plus 3, I'm sorry, 2 plus x cubed. 2 plus x cubed. So we're going to plug in f everywhere, or yeah, we're going to plug in f down here. We're going to plug in this, x to the fourth, everywhere we see an x here. Okay, well that's easy. We just plug in an x to the fourth in there, so we're going to erase this x. We're going to put x to the fourth in there. We're going to do some more erasing than that. And we'll just put cubed here. And of course that simplifies into x to the 12th. But this is just a quick recap of the composition of a function, right? And we need to know that because we're about to get into, and I'm really sorry, but some very tedious stuff. Okay. So we'll put this out. Actually, let's just put that by itself here for right now, and we'll talk about it. And I'm actually going to tie in another theorem with it. Okay, because the extended power rule I think is I mean it's the same thing really, but it's just to me it's more precise. Right. So let's start from the top. Using the chain rule to differentiate a composition of functions. So how do we differentiate a composition of functions? Okay, so far we've only differentiated just functions, right? Uh, just different degree functions. Let's see, rational functions also. Okay, but how do we derive composition of functions? Well, this is the chain rule. All right, now follow along here. But down here, the extended power rule is again more precise. Uh, and in fact, well, no, we'll talk about it. No, we are going to go to theorem 2. We're just going to go straight to theorem 10, okay? Because again, it's just more precise. So suppose that g of x is differentiable function of x. Then for any real number k, okay, so if we have some g, the g of x is going to be a composite function, all right, and it's raised to some k power. Well, what you're going to do is pretty much what we know about differentiating, right? We're going to move the k out front, and that's what we do here, and then we're going to go down 1. Okay, so we're going to reduce the exponent by 1. But then what we're going to do is we're going to differentiate what is inside the parentheses. Okay, we take the derivative of what's inside parentheses, and again, this also says that. Okay, it's just this again. We see the actual the derivation process. That's even the phrase, where we do indeed take the exponent put out front and reduce it by 1. But again, this is the exact same, and let's actually snip. We're going to snip this theorem, put it on the next page as well as example 3. That way you can follow along with it nice and neatly. Okay. So example 3, we need to differentiate. All right. So I guess maybe I think these will just get their own pages. I can't remember if this is long or it's not that long, but they'll get their own pages just to make it look pretty. So anyways, A, we need to differentiate y, and y is x squared plus 3 all squared. Okay. So according to the extended power rule, what we're going to do is we're going to first rewrite this. Let's let's do it this way. Okay. All right. So the first thing we're going to do is what we're used to doing, and dadgummit, we're going to have to move this down a little bit. There we go. All right. What we're used to doing first is putting this 2 out front, and then reducing this 2 down 1. Okay. So that's going to now look like 2, and then we have x squared plus 3. And of course, it's raised to the first power, but we don't write that. Now what we have to do is differentiate what's inside the parentheses. Okay, well, and luckily this is pretty darn easy, right? And of course, my rule up here says I differentiate, the parentheses first. First things first, I do that. And then I multiply by the derivative of what's inside the parentheses. So what's inside the parentheses? Well, that's, I made it nice and pretty for you. It's yellow. So we multiply it by 2x, and that's it. Just simply 2x, okay? And then, of course, this turns into, looks like the 2 and the 2x, they multiply with each other, so 4x, and then x squared plus 3. Right? And that's it. Um, that's A. That wasn't too bad. That one, I mean, that one, and I guess some of these aren't too bad, but I'm just gonna give you full disclosure. They get way worse. Okay, sorry. Normally I'm not like that. Normally I say, hey, it's not so bad, but yeah, I'm not gonna lie to you. It gets pretty tedious, and honestly, it's gonna get so tedious that I may make a mistake in this lecture again. All right, so B. Okay, so I wrote it like this. I did 6, and then put in yellow x cubed minus 5x plus 1. That's all raised to the 10th power. Okay, so again, remember, I take this 10, I put it out front. Okay, so it becomes, there's like a 10 times 6 there, and that 10 goes down 1 to a 9. Okay, so keep all that in mind. I'm just gonna write that right underneath it. So the 10 goes out in front, so it becomes a 10 times 6, and of course we know that is 60, so let's just go ahead and put 60 there. And we've got x cubed minus 5x plus 1, and then that's raised to now the 9th power, right? We're going down 1. All right, now we have to multiply it by the derivative of what is inside the parentheses. Well, that's going to be 3x squared minus 5, so times 3x squared minus 5. Okay, just make sure I put them in parentheses. And that's it. That is the chain rule for that problem. Okay, and again, it gets worse, but it's just the way it is. There we go. So worried there, my internet popped out. I'm always worried that my internet's going to just cut out, especially during a lecture. Okay, and let's actually we'll do one more with the extended power rule also on the same page, but then we're gonna not do that anymore. I remember when I was in school. I'm not that old, just for reference, but when I was in school, my professors, and honestly, many of them here at Ball State still probably do this. My professors would write on the board, and then they'd have to write this entire theorem out on the board, and then as they were working on the problems, they couldn't erase it. It was just in the way, right? But luckily, I'm younger. I know my way around technology. Not saying that they don't, but I prefer to use it, so I can just snip it. Crap, I'm gonna have to. I'm gonna do it again. So let me just go ahead and do it one more time, so I can just seamlessly go into uh, part B without having to do this. Oh, cut that off. keep cutting off the problem down here. So let's start on this side now. I don't actually know if you can see where I'm snipping. All right. Now that recess is over. Let's really begin now. Okay. So we're going to do it the same way we've done it before. What we're going to do is we're going to go ahead and just simply, oh yeah, yeah, we'll do this. Okay, raised to the 1/2 power. We know the 1/2 power, that's the square root, right? But anyways, so we're raised to the 1/2 power. We know, again, what I'm going to do is I'm going to put the 1/2 out front, and then I'm going to go down 1. So 1/2 minus 1 is going to be a negative 1/2. Okay, so again, I'm going to just simply rewrite that beneath it. So I'm going to have 1/2 times 1 plus x cubed raised to the negative 1/2. And then we're going to multiply that by what's on the inside there, the derivative of it. And the derivative is just simply a 3x squared. Okay. And then we can polish this up. Let's go ahead and fix this. Let me kind of make this 3x squared a little bit smaller. See if I can't just put this all on one line times 3x squared. I don't know if that did anything. Okay, so we end up with this is going to be in the denominator because it is raised to the negative 1/2. Okay, so since it's a negative exponent, again, we move it to the denominator to make it a positive exponent. It's also a square root. I'm just going to go ahead and put it as a square root, right? Well, this is obviously on the numerator as well as this 1, and then this 2 is on the denominator. So I'm just going to combine all that together, all that knowledge together, and I'm going to have, let's do the denominator first because it's longer. I'm going to have 2 on the square root of 1 plus x cubed all under 3x squared. Okay. And in case you're wondering, the reason why I said we're going to start with the denominator, writing the denominator first because it's longer is because I have a tendency to just say, okay, so I'd have 3x squared, and then I'd write, you know, the denominator, but it would I'll say that worked out pretty well. But most of the time it doesn't fit if I do it that way. But if I do the longest one first, you know what? Never mind, forget it. I'm babbling. That's what I do. It is literally my favorite thing to do. So B. All right, so let's go ahead and rewrite this now. Okay, so again, as we've seen on the previous sections, we don't like to deal with the exponent being on the bottom of the exponent being in the denominator. Okay, so let's go ahead and rewrite this first as 5, and then we're gonna go ahead and put this as 1 minus x squared, and then all that is raised to the 3rd power. Okay. Again, same procedure. I'm just taking this 3, putting it right here. 3 times 5 is 15. This 3 goes down to a 2. Okay, so I'm going to write that. So I'm going to have 15 and 1 minus x squared. And that 3 goes down to, oh, I messed up. Yep, that was an error there. Okay, so let's start over. Not start over, but let's see where I've messed up. Okay, so when I rewrote it, I forgot to write the negative exponent there. But, I mean, same procedure, obviously. I put the negative 3 up front. That turns to a negative 15. And then this goes down to a negative 4. Okay, so I messed up a tad there. That's all right. At least I caught it. Negative 15. 1 minus x squared. And then, like I said, this goes down to a negative 4. All right, and then times, well, what is the derivative of what on the inside, right? What's the derivative of the inside there? Well, 1 minus x squared, that just becomes a negative 2x. So times a negative 2x, right? Because again, that's negative sign there. All right, and then we can just kind of mush things together. We'll end up with a looks like a positive 30x, right? A negative times a negative. So I'm looking at this negative 2x and a negative 15. So we have a positive 30x times, and this needs to be in the denominator, but it's written for the exact same there. Okay, and actually let's just go ahead and snip it as it's written in the denominator. Like this. Okay. I mean, they are the exact same thing. It's just um, uh, we don't like negative numbers as much as you don't like negative numbers. So it's the same thing. We'll put is equal to. How about that? Bam. Look at that. Alrighty. Oh man. Oh, this is awful. I told you. I told you. It only gets worse. And this is one of those cases. All right, so this time we're not gonna put the rule up here. Instead, we're just gonna go after this. All right. All right. So A looks like a doozy, and that's because it is. Okay. But before we begin this, remember what we saw on the previous section. I think it was the previous section. The product rule, right? The product rule is the first product, right, or the first term, first times the derivative of the second, plus the second times the derivative of the first. Okay, so let's get going. Okay, here we go. The first times the derivative of the second, so we're going to say, let's see, how do we, maybe we can do, I forgot what I did. Okay, so I did first, trying to remember how I did my color coordinations there. First times the derivative of the second. Okay, now the derivative of the second, let's do, well, I didn't really think this through, how I should teach this. Okay, we're just going to attack this. I'm not even going to do the color coordination there because there's going to be lots of stuff just going on, and I'm not sure where my brain will be at the end of this problem. So we'll just write this 3x minus 5 raised to the fourth power. So that's first time, and then times the derivative of the second. Okay. Now the second is 7 minus x raised to the 10th power. What is the derivative of that? Okay, well, let's actually move this to the left a little bit. Okay, what is the derivative of that? Well, it's going to be the 10 goes out front, and the 9, or the 10 goes down to a 9. So we'll have 10, and then 7 minus x, Sherman, 7 minus x raised to the 9th power, times the derivative of the inside there. Well, the derivative of the inside there is just simply a negative 1, right? So it's going to be times negative 1. Well, the negative 1 times a 10 becomes a negative 10 times 7 minus x raised to the 9th power. Okay, so that's very fast, I know, but that is the derivative of my second term. So as I said, it was first times the derivative of my second. So my second is negative 10 times 7 minus x raised to the 9th power. So that's first times the derivative of the second. Okay. Then we've got plus, and we're going to have to just put this on the next line. I'm sorry. So plus, we'll put that down there. Plus the second term times the derivative of the first. So the second term, that's pretty easy. We'll just write the second term. So that's going to be plus, sorry, 7 minus x raised to the 10th power. and then times the derivative of the first. Well, what's the derivative of the first? Well, let's write it out down here. 3x minus 5 raised to the fourth power. Okay. The derivative of it would be 3x minus 5 raised to the third power times 3x, and the 3x and the 4 multiply to get 12x 3x minus 5 cubed. Okay, and I'm sure that's good. Yeah, that's good. Okay, so the second here again would be the derivative of the first, which was 12x times 3x minus 5 cubed. Okay, and this actually really sucks that I couldn't put this all in one line. Let me see if I can try. How about this? Let's try this. I'm just going to rewrite it, but a little bit smaller, because it would really help driving this next point home. And honestly, I don't need to write parentheses there. It helps, but since it's all multiplication, it's not necessarily needed. Because 3 times 4 times 2 is 24, and 2 times 3 times 4 is the same thing, if that makes sense. And then 12x. All right, so I was able to write this in one single line. I guess that would be our downfall of not writing it on a chalkboard, huh? Okay, so let's erase this and move this up. Okay. And hopefully I copied it down right, and we'll know here in 1 second, maybe 2 or 3 or whenever I get done here. Okay. Whew. So the reason I wanted this in one line is because now this is a jumbled mess, no doubt about it. But we can kind of see something here, can't we? Okay. Hopefully we can see something. We see that this is the first term, as awful as it is, and this is the second term, again, as awful as it is. Okay. Well, we see we have a 3x minus 5 raised to the fourth power and a 3x minus 5 raised to the third power. So it looks like we can factor those two out of those two terms. Okay. And we also have a 7 minus x and a 7 minus x. Okay. At least one's raised to 9, one's raised to 10. So we can factor that out. Okay. And we also happen to have a negative 10 and a 12x. So it looks like we can factor a 2 out. Okay. So let's go ahead and do that. So we're going to factor out a 2. Let's put this in yellow. No, that's too green. We're going to factor out a 2, and we said we're going to factor out a 3x minus 5. So 3x minus 5. Okay, what is the highest power? It looks like it's 3 because this is a 4, this is a 3, so we can factor out this raised to the third power. We can also factor out 7 minus x. Well, the highest power, the highest we can factor out, we have a 9 and a 10, so we're going to factor out a 9. So we'll have a 7 minus x raised to the 9th power, right? And what remains? Well, if I take 2 out of this negative 10, I end up with a negative 5, so I'll have a negative 5 right here, so negative 5, and then it looks like I'm going to have a 3x minus 5, so 3x minus 5. And it looks like I factored out the 7 minus 9, so that's going to be it for that. I'm pretty sure. Yeah. Okay. And then I'm going to have plus. Right, plus. And again, I factored out 2 from the 12x, so I'm going to have a 6x. And then I factored out 9 of the 7 minus x's, so we're going to end up with a 7, just simply a 7 minus x here. And then I factored out all 3 of the 3x minus 5s, so that is that. Is that right? I believe that's right. Let's go ahead and examine again. Like I said, it gets pretty wild pretty fast. Uh, X. Where's my X? Did I mess up that X? One moment. Give me like 30 seconds to check this out. It happens. First times derivative second plus the second times the derivative of the oh, I think I did. Shoot, it's just supposed to be 12, right? 3 times 4. Ah, it is supposed to be. Okay. Well, that was an error. I knew it was going to happen. It's embarrassing when it does. But what are you going to do? Let's see if we can't move these a little closer so I don't have to rewrite them. Okay. Now I think, what was it? I'm looking down here at this line because um, well, we factored it out, and I'm really not in a hurry to distribute and stuff, but I guess we will, because the textbook probably wants to do it. All right, so I think that's good. 2, 3. Okay, so let's just go ahead and go, because apparently since the textbook is proceeding with us distributing in this area here, we will as well. Okay, we're gonna do some in our head though. Actually, we're not. Okay, so negative 15x plus 25, and then plus 42 minus 6x. Okay, and let's go ahead and combine the like terms, because again, like I said, well, no, maybe it'll look better for the notes. So there's going to be a toolbar that gets in the way, so let me move that real fast down here. And again, I don't think you can see it. I've kind of watched my lectures. Uh, All right, combine these like terms. We have the negative 15x and negative 6x. That makes a negative 21x. So minus 21x. And that 25 and a 42 gives me 67. So plus 67. And that should be it. Let's make double sure here. Yeah, we're good. And real quickly, this error that was up here, I did second times the derivative of the first. Uh, it happens. Hopefully, you don't hold it against me. But let's do B. All right. And B. Well, I can't remember. I don't know if B is as tedious. It probably is. Division is always tedious. Division is always way worse. All right. So here we go. All right. So keep in mind. Well, let's just go ahead and rewrite it. So B. If I rewrote this, it's going to be x plus 3 over x minus 2, and that is all raised to the 1/4 power, okay, because this is a fourth root up here. Okay, so beginning here, well, we can actually do the chain rule part first, right? So we're going to do a chain rule part first, so we can say 1/4 times x plus 3, x minus 2, and then 1/4 minus 1 is going to be a negative 3/4, so negative 3/4. Right. Now, I don't think it's too bad. If you recall, now we have to differentiate what's in this parentheses here. Okay, well, on the previous page, it was the quotient rule, right? It was low d high minus high d low. Okay, low d high minus high d low. So what we're going to do is we're going to go ahead and differentiate this. All right, I'm definitely going to be running out of room here. So let's put it down here. We'll try to make this a little smaller. Okay, so again, low d high minus high d low. So it's going to end up being, let's go ahead, let's do this on the next page, x plus 3, x minus 2. So the derivative, x plus 3, x minus 2. Okay. So it's going to end up being low x minus 2 times the derivative of the high, which is just simply a 1, low d high, minus high d low, so x plus 3. And then, maybe this ain't so bad. I don't know. What was I freaking out about? All right, all over low squared, x minus 2. All right, so if I follow this up, I've got x minus 2. So, I mean, being multiplied by 1, it really, nothing changes, right? So it's just basically going to be x minus 2, and then it's going to be minus x minus 3 all over x minus 2. So the x's cancel, so we end up with a negative 5. So we have a negative 5 over x minus 2. Okay, low squared, sorry, low squared. Low squared. Okay, and let's go ahead and just, because I know that it gets a little messed up here, let's go ahead and do this. Let's make it green. And I make it 20. Okay. Low D high minus high D low. And I can't remember if that's exactly what I put last time, but that's what we're going to put through here. And again, low times derivative of high minus high times derivative of low all over low squared. Okay, so negative 5, try to remember that, negative 5 all over x minus 2 squared, quantity squared. So it's going to be, I never forgot, good job, Sherman. Negative 5, x minus 2. Okay, so, was it negative 5? Yes. Ugh. Okay, so times a negative 5 over x minus 2 quantity squared. And not necessarily sure how much they want this done, but let's see if we can't clean this up just a tad. So I know that this is going to end up being, this term here is going to end up going, this is, you know what, we're just going to leave it like this. Actually, you know, we will actually talk about it, but then I'm going to snip the actual solution. Okay, so real quickly, we know that this entire term is going into the denominator because it is raised to the negative 3/4, right? And then we have x minus 2's, they can combine, and of course the negative 5 goes on the numerator, and then that 4 stays on the denominator. And like I said, we're just going to snip this because it's a lot of writing there. Where are we at? Example 5. It's not the worst thing. And while we're at it, we're just going to check our work. Alright, so we've got 1/4, okay, good, we're good. Alright, so next, I think this is the last one for the day. Yeah. Oh, this is actually, this looks kind of short. It's not a lot going on here. I mean, it actually is a lot going on, but the solution to it is not nearly as bad as you may think. Okay, so all we have to do is kind of do the chain rule twice, essentially. Okay, so let's let's do this. We're going to have x squared plus, and then let's do, no. We'll do it this way. We'll do x squared plus, and then put this in blue. Okay, hopefully this is gonna help. Okay, so first things first, it's not abundantly hard. We're gonna have to put that 7 out front, right? So we just simply put the 7 out front, and then what remains is, well, just rewrite this. Okay. Now, what you're thinking is, okay, so it appears that I'm going to have a chain rule within the chain rule, okay, and you do, okay. But let's finish up the first chain rule first, okay. We did that part. Now we have to find the derivative of the inside here, okay. Well, the derivative of the inside is just going to be, well, it's going to proceed how you think it does, okay. And here's what I mean. It's going to be this and then times 2x. Okay, and again, that's because that is the derivative of, obviously that, right? And so it's times 2x, and then we have the plus here, so let's actually put a parentheses there. Okay, all right, and then plus, all right, well, now we have to figure out what the derivative of this term is, okay? Well, we just have to perform the chain rule on it, right? So it becomes 4 and then 5 plus 2x, and hopefully I'm not running out of room here. 5 plus 2x, and that goes down to a 3 times the derivative of the inside, which is 2. Okay, and of course the 2 and the 4 they can multiply, and let's actually we'll just fix it on the next line. Okay, so again, I don't feel like I covered this too well, so I'm going to go over everything I just said again, just to really drive the point home. Plus 8. I'm going to do it every time. Okay, and I think that'll do it. Okay, so starting from the top again, I'm going to do this chain rule like you think it works. Put the 7 out front, this goes to a 6. Okay, and of course that's what we see. Well, it goes to a 6. Why do I have it as a square? Okay, and it goes to a 6. And then we can just write what's in here. But using the chain rule, now we have to get the derivative of what that is, okay? So what is the derivative of what is inside the parentheses? Well, what is the derivative of x squared? Well, that's just simply 2x. And then we have to figure out what the derivative of this is. Well, we have to just perform the chain rule on this. We put the 4 out front, and that goes down to a 3. And luckily I did it right this time. And then we take the derivative of what's inside the parentheses, which is, what's the derivative of 2x? Well, that's just going to be a 2. Right? And then we just clean this up. We have, this term here, which is the exact same as the one above it. And then all I did here was basically I combined the 4 and the 2. 4 times 2 is 8, and that's really realistically all I did to clean this up. And I'm pretty sure this looks awful. Yeah, I mean it being raised to the 6th power and stuff. We are not simplifying that at all. So, and if anything, I mean that's pretty simplified if we're being honest. So that's example 6, and then we'll do the section summary. And that concludes today's lecture on Chapter 1, Section 7.